Hello, my name is Rafael Benevides, and this presentation is about Istio and Service Mesh on top of Kubernetes. So let's start. If you want to have access to the slides, you can go to this link here, bit.ly/istio-kubernetes. My name is Rafael Benevides, as I said, and I work at Oracle as a cloud-native development advocate. So, before talking about Istio, we need to understand how we got here. So, before starting to produce microservices, we need to go through a kind of evolution process, where the first step of this evolution process is to reorganize your team to adopt DevOps practices. Then, the next step of this evolution process is to have a self-service, on-demand, elastic infrastructure. Then you start to have automation. What kind of automation? You can have a build automation, tests automation, infrastructure automation, and of course, a CI/CD deployment pipeline would be the next step. So you will automate how you get your source code from your repository to production. And once that it lands to production, you must choose advanced deployment techniques. And then you are ready to have your first microservice, and who knows, maybe you can become the next Silicon Valley unicorn. Okay, but if you think a little bit, with Kubernetes, Linux, and Istio, you will have a lot of unicorn power on your application. Let's see why. First, we had Monolith's application for many years. Of course, they are composed by modules. And then we decided to turn these modules into microservices. But the difference is that those microservices don't live together, and they are not deployed together. Instead, they are spread over your network and different on different servers, creating a network of services, a mesh. Each microservice own their data. Some of them have multiple points of entry, and of course, all of them have a pipeline, a way to get your source code from the repository and place it on production. Let's recap some of the microservice principles. The first one is to have a deployment independency. Why? Because we need to be more agile, because we need to place a change on production as faster as possible. No matter what time, what day, we just need to be capable of deploying that piece of change, that piece of code. Of course, to achieve that, we need like the item number 4, we need to be focused on the API. And of course, API are contracts, but those contracts need sometimes to be evolved. That's why we need evolutionary design, like the item number 10. Things can fail, so that's why I need design for failure, item number 9. We treat those APIs not as projects, but as products where we have a certain level of quality. We have customers, we have someone that will take care about this product. What else? Decentralized governance, because we don't need to have, we don't want to have someone who will centralize the application that's not agile. So yeah, and then some decentralized data management. So these are some microservices principles that I suppose that if you were interested on service mesh, these are concepts that are familiar to you. In fact, what we see today is that we are producing microservices with many databases. They are running inside containers on top of Kubernetes. This is the new school. This is what we see in this new world of cloud-native applications. But although it's something new, microservices in fact is the same thing about distributed computing. It's the same thing that we saw on Corba, it's the same thing that we saw in SOA architectures, service-oriented architectures. It's all about distributed computing. And because we are talking about distributed computing, we need to recap also some fallacies of distributed computing. There are 7 fallacies. Let me mention them. We tend to think that the network is reliable. We tend to think that the latency is 0, which is not. That the bandwidth is infinite, that the topology does not change, there is one administrator, transport cost is 0, and the network is homogeneous. They are totally wrong. They are all fallacies. Okay? So, to mitigate problems with distributed computing, for example, if a microservice fails, what we don't want is to have a cascading failure. So what we do to mitigate those problems? Well, we embedded certain capabilities inside microservices. So for example, if we have a microservice A that needs to talk to a microservice B, what we do, we place a discovery mechanism on it, because we need a way that the microservice A will find the microservice B. We place a load balancer also. It can be a client load balancer or a server load balancer, because we can have multiple replicas of the service B running in parallel. So we need to balance the requests among those replicas. We need a resilience, because service B can fail, service C can fail, so we need a kind of resilience. We need metrics, and we need tracing. And another recap here is the history of microservices. Everything started in 2006 when the AWS EC2 has been released. Then we had the era of fat jars with Drop Wizard and Vertex. So we started to think about a lightweight deployment without using the big old fat application servers. And then something very important happened. Netflix, one of the first companies that produced microservice, they released their product Reborn Historics in Eureka in 2012. Why is that important? Because Netflix went to the public and said, hey, 1/3 of the internet traffic on Saturday night, they run through our servers, and people were amazing. They want to know how they could scale. And they, of course, explained their architecture and released their project as an open source project, which helped a lot other companies to start producing what would become microservices. And of course, since 2013, 2014, we saw the perfect storm for microservices. We had Spring Boot, it's still very popular. We had the release of Docker, then those containers could be managed by Kubernetes. Microservice was finally defined by ThoughtWorks, and since 2015, 5 years ago, we are producing cloud-native applications. But what's wrong with Netflix OSS? The problem is that it's Java only and adds a lot of libraries to your code. And let's think for a moment. No matter if we are producing microservices using Node.js, Java, Python, Go, we need to have certain capabilities in our microservice. First one is the API, right? We need a way to communicate with that microservice. We need an API, a contract. Then we need a discovery mechanism, a way to find that microservice. Then we need an invocation, a way to invoke that API. Is it synchronous? Is it asynchronous? Is it a REST endpoint, GraphQL, messaging? Well, we need elasticity because, as I said, we can grow the number of replicas of our microservice. We need resilience. We need, because something can fail, we need to be prepared for that failure. We need a pipeline to get our source code to production. We need authentication because not every information is public. And we need observability covered by the 3 pillars of observability: logging, monitoring, and tracing. If we adopt Kubernetes plus some open source projects, we will be well covered because Kubernetes gives us discovery, invocation, and elasticity for free. And with other open source projects like Jenkins for the pipeline, the Kibana stack, ELK or EFK, Elasticsearch Fluentd and Kibana, Elasticsearch, Logstash and Kibana, we will be covered for logging, Prometheus for monitoring, and Jagger for tracing. And what about Istio? Well, with Istio, which is a service mesh implementation, and by the way, what is a service mesh? Service mesh is when you have a dedicated infrastructure that will cover a service-to-service communication. Usually, it's implemented by having a proxy in front of your application that will handle this kind of communication, network communication, okay? So with Istio, you will have a better discovery mechanism. I will mention that I will talk more about that later in a demo. We will have resilience. We will have authentication because Istio provides a mutual authentication using MTLS. We'll have monitoring for free. We'll have tracing for free. So with microservices and using Istio, Kubernetes, and plus some open source projects, you as a developer will just provide the API. The other things we will gain for free. So before Istio, you had to implement those things that I said: discovery, load balancer, resilience, metrics, tracing inside your application for each microservice. Now, with Istio, those capabilities are placed inside a sidecar container. This sidecar container intercepts all network traffic, inbound and outbound network traffic, and redirect that traffic to this sidecar container that runs a proxy. The proxy used by Istio is the Envoy proxy. So let me show to you Envoy proxy here. Envoy is an open source edge and service proxy designed for cloud native application. It was written in C, so it's it's lightweight and very well performatic. So this is the idea of the sidecar. It will not drive your application. It's the responsibility of your application to be the engine of your vehicle, but it can carry a special thing, a sidecar, inside its sidecar. Okay, so what you can do with service mesh? Well, first, as I said, it's polyglot. No matter what language you are using, it's code independent. Allows you to have intelligent routing and load balancing, promoting an easy way to perform A/B tests, smarter canary releases. I will show that to you in a demo. It allows you to have chaos test with fault injection, resilience with circuit breakers, observabilities with metrics and tracing, and a fleet-wide policy enforcement. And how does Istio work? Well, we have a control plane that has at least these 4 containers. We have the pilot, which is responsible to send the Istio configuration to all Envoy sidecars. And we have the mixer that collects the information that comes from the sidecar. That information can be used for quota, for telemetry, for rate limiting, for access control list. We have Galley, responsible for the validation of the configuration of the cluster of the mesh. And we have Citadel that creates the digital certificates that will be used with MTLS. The communication between the sidecars can be HTTP 1.1, HTTP 2, gRPC, and of course, if it's not one of these protocols, it will use TCP with TLS, promoted by the Citadel. So what we see now in 2020 is that we don't need the Netflix OSS anymore. We don't need Hystrix, Zool, Ribbon, Eureka. We don't need to implement open tracing by hand because Jagger is part of Istio, so no matter what language we are using, we are very well covered to just take care of the API itself. So let's see that working. First one is related to observability. And to demonstrate observability, we need to see that I have here in my demo, let me start producing some requests in my demo. It's two microservices, one called Hello World and another one called Olá. Olá is hello in Portuguese, and we have two versions of Olá. We have version 1 and version 2. So let me start sending requests to this cluster. We can see the reply here. And also, let me show something to you. Let me get the pods in the Istio system namespace. We can see here that we have Grafana, we have Prometheus, we have Kiali, and Istio tracing is Jagger. Okay, so let me show first to you Prometheus. Grafana. We have Grafana, which is part of the Istio installation. We can choose a dashboard here, so let me show to you the performance dashboard, where you can see the information related to CPU, memory usage, network usage. What else? Let me open another one, the mesh dashboard, which is running here. Let me just Grafana. Yeah, Grafana seems to be a little bit slow, but let's don't worry about that, okay? Because I want to show to you also another project which is called Kiali. So we have Kiali. Kiali allows us to see a graphic visualization of our load. So we can see here the traffic flowing through Hello and through also the two versions of U1, 50% for each. And they are also reporting those requests, those span requests, to the Jagger collector, because Jagger is also part of the Istio observability together with Prometheus. So we have Prometheus as well. Prometheus allows us to have information about many types of metrics, like for example Envoy metrics or the container memory for all namespaces. Let me show that to you. Or for the specific namespace microservices. So we can see here that the memory consumed by the main application and by its proxies. And finally, we have also Jagger deployed as part of this cluster. Let me show to you the dependencies so you can have an idea of the Istio architecture. So it's loading here. Okay, and now we have Kiali where we can see the graphic. Let's go to Jagger. So the traffic goes through Istio Ingress Gateway. We have the proxy receiving requests, and then the proxy send the information to the application. Then it will talk to the next microservices proxy that will talk to the application. And they all are reporting to the mixer. Okay, so, and of course, if we Jagger here, we can look for the Istio Ingress Gateway, get the traces, and we can see here, for example, if we open this trace here, we can see that the traffic went through the ingress gateway, then we had the proxy receiving the inbound requests, then the application is called, so the application receives, it's a JAX-RS server, okay, then we have the JAX-RS client invoking the next microservice, which the name is Hola in the port 3000. And before calling this URL, the outbound traffic is called again. So we can see here that the outbound traffic is intercepted again before calling the next microservice. Of course, the proxy of the next microservice will intercept the inbound call as well. Let's see also Grafana. We have here the workload dashboard. So we can see the incoming request volume, incoming success rate, and so on. So this gives us an idea of observability that you will gain for free, because the proxy will report that those metrics, those observability data to Grafana, to Kiali, to Prometheus, to Jagger. Okay? So what else we can do with Istio? Well, before that, let's see how we can, before doing some things here with Istio, what we will do is to understand how we can inject a sidecar in our application. We have two ways. We can use the istio-ctl command with the parameter kubeinject. Then you will give the name of the deployment, the name of the file. That will generate a new file with the proxy declared inside your pod. And the way that I did here, which is the recommended way, is you just need to annotate your namespace with the label istio-injection equals enabled. You just need to do that, and Istio you will automatically place a sidecar container for you. So let me just show that. Let me show my microservices namespace. You can see that I have two containers per pod. Okay? Let's see what else we can do. We can do traffic control. We can perform a blue-green deployment. So what is a blue-green deployment? A blue-green deployment is when you you get your source code, place it on production in a parallel environment. That usually we call that as blue or green. And once that this is running on production, we can just switch the traffic from one version to another. If something goes wrong, we just change the traffic to the to the other version that's also running on production. Let's do that. You can see that I have the version 1 and version 2 here of Ola. And what I will do is use Kiali. So let me get here the services of Ola, right? Let me go to traffic and select here Ola. Better. Services. Okay, now we go to Ola, traffic, and I can select here, for example, let me delete the current data and create and suspend the traffic. So what I will do is suspend the traffic on both and keep connected only v1. So once that I create that rule, you will see here that it will change and have all the requests going to v1. So let's wait. So there it goes. Only v1 is receiving requests at this moment. Okay? Or I can disconnect v1 and note here that there was no downtime. What I will do now is update the traffic, disconnect v1, connect v2, and once that I update the rule, we will see the behavior changing here. So it's applying the rule. Still applying. Yeah, and there it goes. We can see only v2 receiving traffic. Okay? And of course, when I delete that rule, the behavior will be back to normal again, where v1 and v2 receives requests. Okay? Let's wait. Yeah, there it goes. v1 and v2 are receiving requests now. Another thing that we can do with Istio is to have a Canary deployment. So what is a Canary deployment? Canary deployment is when, before let me tell you the story behind Canary deployment. Canary deployment received this name because of the British coal miners that used to carry a canary to the mine, to the coal mines, to the mines. The idea is if there was a gas leakage, then the canary would stop singing, and it means that they had a problem. They need to run away as fast as possible from the mine. Of course, the canary would survive because they had a Canary Resuscitator where they just close the door that had the contact with the toxic gas, and they opened a cylinder with a fresh air, and the canary would survive. Okay, but in software, this means that we will place a version of our software on production. That this version is called the Canary version, and then we will stop sending traffic to that version. And that means that if the canary would be happy and singing, the Canary version of course, then we can stop and increase the number of traffic on that Canary version until it completes 100% of the traffic. With Istio, if there are no Istio involved, on Kubernetes, if there is no Istio involved, the traffic is always 50-50. But with Istio, we can control the number of requests on a specific version. So let's see that working. I will use Kiali here, okay, and create a weighted routing by sending 80% of the traffic to v1 and 20% of the traffic only to my Canary version, which is v2. So when I create the route, we will see here that V1 will receive much more traffic than V2. Once in a while, we can see V2 here. Okay, so V1, now we have V2, and then we will have a bunch of V1s again to receive V2, to have the traffic go into V2. Okay, of course, we can change the mixture. So I will now make the opposite. More traffic will go to V2 now, and V1 will receive only 16% of the traffic. So now, let's wait for the rule to be applied. Let's wait a little bit more. And there it goes. We see V2 receiving much more traffic than V1. Okay? And we can do a Canary release based on other information. So for example, let me delete this traffic and create a traffic based on a match routing. So based on the header, on the scheme, or the method. In this case, I will get a header called test. If test matches Rafael, I will send the traffic to version 2. Okay? If the header contains nothing special, I will send the traffic to version 1. So note here that when I add that rule, headers test equals Rafael, send the traffic to V2, any other request sent to V1. When I create that rule, we will see that only V1 will receive the traffic. Okay, so let's wait a little bit. We have V1 receiving traffic, but if I call my microservice using a specific header, like for example any other header, okay, we'll see the reply from V1. So we have V1 receiving requests, but if my header is exactly Rafael, we'll see V2 replying. Okay, so this is really nice for A/B testing. Okay, let me delete this traffic, this rule, and then we will see V1 and V2 receiving traffic again. Okay, what else we can do with Kubernetes, with Istio? Well, we can perform a dark launch. So what is a dark launch? Dark launch became very popular when Facebook released Facebook Messenger. Facebook Messenger was placed on production 1 year before we seen it. How we can do that with Istio? Well, with Istio, we can mirror requests to a version that will receive requests, but the user will never see it. So let's perform a dark launch. In that case, instead of using Kiali, I will use a script that will load an Istio file. Let me show how is the file to you. You can see here that it will create a virtual service that all requests are going to V1, and V2 will receive a mirror request. Okay, so let me clear. Let me create the destination rule, and now let me perform a dark launch. This script just applied that virtual service. Okay, now we have V1 receiving requests, but if we take a look, if we get the logs in the namespace microservices for the pod V2 in the container hola, we will see that v2 is receiving requests. Note here, I will stop sending requests, okay? And I forgot to say that I want to follow the logs. It's loading all previous logs until it gets stopped, okay? Let's wait for that. And there it goes. The logs for v2 is stopped. When I start sending requests, the user will see only v1, but v2 is receiving requests as well, because the requests are being mirrored. Okay? Let me open another window here. Because I want to show to you another thing that we can do with Istio, which is the service resilience. And the way that I will demo the resilience is because I want to avoid a failure, a cascading failure. So what I will do here is remove that rule, okay. Now that I have the rule removed, we can see the expected behavior of v1 and v2 receiving requests. But I have a special script here that will make my v2 fail, because I will change a flag on v2 that will, instead of returning the script, it will return a 503 error. So let's call that script. And now we can see the following requests to v2 will return a 503 error. But everything's still working here. We don't see v2 anymore, although v2 is receiving requests. Okay, so what's happening here? The proxy of the application will send requests. It will get an error. It will automatically perform a retry. We can see that request is going through v2 here. v2 is receiving request. It will automatically perform a retry, and it will land on v1, which is working. So that's how you can have resilience on your application. If we make v2 work again, so instead of returning a 503 error, it will return the normal behavior, just replying. We'll see that v2 will have the reply here again. Okay. So the following requests will return a 200 status. v2 is receiving request, and we have now the reply from v2 working. Perfect. Okay, what else we can do with Istio? We can perform chaos testing. How we can do chaos testing? We can create a delay, a fixed delay in 50% of the case, which is what I wrote here. So I have a destination rule for a delay, virtual service delay. So this file will create a fixed delay on 50% of the time for v2. Okay, so let me apply that rule. A script Istio delay. And now every request on v2 will take like 7 seconds to reply on 50% of the time. Okay, so there it goes. We can see, oops, here. So yeah, there it goes. We have an answer of v2 after 7 seconds. Now we are waiting for another delay. That's very useful for testing purpose. What would happen if a specific microservice start to degrade its performance? We can see that happening. Okay, let me just clean that rule and make it work again and see what else we can do with Istio. We can create access control list, blacklist or whitelist. We can deny everything, or we can allow only specific requests. For example, suppose that you want to deny everything and allow just customer to call preference and call recommendation. Or we can create a blacklist where we'll deny recommendation, calling preference, or calling customer. And one of my favorite features of Istio is to have the control of egress. We know about egress, it's how we can communicate with our microservice, but sometimes our microservice need to talk to external services. And we can deny or block those kind of requests, because imagine the following situation. Someone is trying to send sensitive data to anywhere in the world. We can deny that request. So let me show that to you by trying to access from a pod the world clock API. In this case, what I will do here is to try to access world clock API. Let me stop this request here. We saw that we had no error. We have 200 HTTP status, but no information were able to work. What I will do here in this case is now allow my communication to go through world clock API. Now when I access the same API that I did before, waiting for the communication, and there it goes, we're able to get the information from world clock API. Okay, so this is one of my favorite features, because it can block, even if your cluster is compromised and someone is trying to steal data, this data will not be able to be sent external. It will be sent to anywhere in the world due to Istio. Okay, Istio is really nice, but we have just 45 minutes to explain all the features of Istio, so I suggest you to go to this URL where you will see a tutorial covering most of Istio features. And of course, I can run this Kubernetes cluster on top of Oracle Linux, which allows us to have a Kubernetes cluster. More information about that you can find in these URLs, developer.oracle.com or cloudnative.oracle.com. This is the end of the presentation. If you have some questions, you can send it also to my Twitter handle, which is Rafa Bene. I suggest you to go to, if you are a Twitter user, just go to @RafaBene, click on follow, and it will be a pleasure to exchange some ideas about cloud native development. Okay, so I really appreciate the time that we spent together, and I hope to see you on next events. By the way, I'm also talking at J4K.io about specifically about open tracing. Don't miss it. Thank you so much, and bye-bye.